Oh yeah, you saw it. All right, let's see. Did it start? Did I start the? All right, you ready, Christian? Class. Christian. Faye. Okay, for those people watching at home, she just gave me one of those cringy smiles, like the super cringe smile, like kind of like the Grinch. You know when the Grinch smiles and you get like that weird, yeah. That was the smile I just got for all those people watching at home, and it's most likely just going to be Christian again, watching and laughing at this. Yeah. All right. So, slope fields. Notas. Here you go. Wow. Okay. Hey. Faye. 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 Okay. And Nephi, if he's awake, hand him the other one. Okay. All right. Slope field, first order differential equations, and slope field. Oh wait. Solve separable first order differential equations. Use slope field to represent a solution of a first order differential equation, and use Euler's method to approximate a particular solution of a first order differential equation. So we're going to focus on these two, 1 and 2 today. Next week we'll do 3. All right, so if a function with x and y could be written as m of x over n of y, where m is the function of x alone, where n is the function of y alone, both m and n are continuous on the domain. First order differential equation is called separable first order differential equation. Okay, so first order separable equation is separable if it can be written in the form of dy dx is equal to m of x over n of y, where m is a function of x alone, n is a function of y alone. Both m and n are continuous on the domains in the terms of differential equation 2 right here. Then you could take this form. N of y dy is equal to m of x dx. And blah, 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 blah. Watch. I'll show you right here. This actually, it sounds more complicated than what it is. Right, Christian? Sounds super complicated, right? You're like, what the hell? So, we're going to take this right here, and then we're going to separate the variables. So, given I have a dy dx 3xy squared. So that means I want all the x's on one side and all the y's on the other. So I get dy is equal to 3xy squared dx. And then to get my y squared over the other side, I'm going to divide both sides by y squared. So I'm going to get 1 over y squared dy is equal to 3x, that's an x, dx. So at this moment in time, all we did is some algebra. So I'm going to take the integration of 1 over y squared dy is equal to integration of 3x dx.
Sorry, no, I'm trying to reverse Google image search what's on his computer. So there's no bug or anything. It's some like drawing and that looks cool, and I want to see if it's like a YouTube video or something.
Oh, Yeah.
Get you to reverse
Okay,
Google
all right. Anyway, so not really focusing on or caring about what we're doing here, right? Okay. All right. So that being said, let's go ahead and integrate this. But before I do that, I'm going to rewrite this. So this one right here, I'm going to say that is going to be y to the negative 2, right? So if I think about it as y to the negative 2, I can integrate it a lot easier. So I add 1, then divide by that number. So that's going to give me 1, so negative 1 over y, because I add 1 and then divide by that, so it's going to be this, right? Okay. Now, dy goes away because I'm doing the integration. But what do I normally add right here? No, we already did the dy. That's the terms of what we're doing. Okay? But don't I normally add plus c here? Yeah, so I'm going to show you right here. I don't add plus c here because isn't this one over here also going to get a plus c? So when I combine the two plus c's, because it would be like a c1 and a c2, and they're two separate c's, but as of right now, I'm just going to put them together and say it's one c. Okay, instead of saying two separate c's, it's just one. So if it's going to be a 2 and a 3 together, that would be a 5, and then I would have to separate those later on. But as of right now, it's just one constant together. Just one constant together. So over here, this is going to give me 3x squared over 2 plus c. So I'm always going to add this to the right-hand side. I don't know why it's always the right, but it's all, you know, that's the right way. Hey, Christian, did you get that one? That's the right way of doing it. Where do we add the c? On the what? On the right. Do you know why that's right? I don't either. That's the right way though. Okay. All right. So now that we have that here, we also have some initial condition. I have initial condition that I have y is 2, x is 1. So my initial condition is, so I can plug this in, and once I plug in my x and y, what would I use that for? Find the c. If I get rid of the y, if I get rid of the x, the only variable that's left is the c, right? So that's why I'm only using one c. Alright, so let's go ahead and plug that in. So that's negative 1/2 equals 3. So that's 1 squared, right? 3 times 1 squared is just 3 over 2 plus c. Minus 3/2. So that's negative 4/2 is c, which is a negative 2 equals c. Yeah.
You just have to find C1 and C2. You just leave it at C.
It's just going to be c because they're combined together. Even though this, I separated this, but isn't this just one problem? It's just one problem here. So I'm separating of what I have. So here's my particular solution here. So I now know what the c is. Okay, so let's see, find the particular solution. Since I now know what the c is, I can go back to this, and I'm going to say that I have change of colors. so let's start by turning this into no more fractions. So if I'm not staring at my phone, I might actually look at this and be like, hey, what's the common denominator for all this? You can throw out a guess. Okay, so now look at the denominators I have. I have this denominator and this denominator. So together, a common denominator would be 2y. Yeah, and I could do that. So I'm going to start by, this is the algebra tip here. So let's get rid of all the fractions by multiplying both sides of the equation by 2y. So I'm going to do that. So 2y to this side and 2y to this side. So if I multiply by 2y over here, y's will cancel and I get negative 2. If I distribute the 2y over here, the 2's will cancel. The 2's will cancel and I'll get 3x squared y minus 4y. And to write this problem correctly, I have it equal to 0. It must be equal to 0. So, because you're really not going to take out the y's and try to make it into a y equals problem. You're going to set it into a relation of 0 equals 3x squared y minus 4y plus 2. This is called my particular solution. That is my particular solution. So a particular solution is a solution that gives you a coordinate that gives you only one line off of that. And then the next part is going to refer to calculators. So slope field represents solution of first order differentials. Slope field, give a picture. Bam. So let's calculate it. So I know everyone brought their calculators today, right? That's what good students do. And can you use this calculator on your test? Yeah. So knowing to use it, how to use this calculator is going to be key. Alright, so let's go to graphs. Here, back it up, change relation, and this one is we have, let's see, it was 3x squared times y go back to it now. Minus 4y plus 2. So that is my particular solution for that. Now with that, my coordinate that was given to me was 1, 2. X is 1, y is 2. So that means that right here is what the point I was looking at. 1, 2. So given that slope and that problem that I have, that differential equation, this is the only one that's going to fit to actually cross through that point right there. So that's what that meant. Now let's go back to, I'm gonna hit doc B and do it again. And no, that's a history menu. Let's see. Now I'm gonna have to look it up. So it would be y prime, which is, nope. X prime X prime equals, I think the problem just said y. Yeah, y. Okay, now I'm gonna have to do this. Since there was an update since last time I did. Alright, going back to my thing, because I was in the wrong menu. That's why I messed it up. Escape, right here, menu, graph, differential equation. There we go. I was in the wrong menu. And we had, this is y1 prime. That's what that means. And then we would have equals y. Oh, I did not do it. Okay, so I screwed up. So for those people watching at home, yes, I had to go look at a YouTube video on that, how to do this. So go back, menu, graph entry, relation, go back up to my first one. I had to change it that say that it's going to be y1. So there we go. All right, so this is going to be the first one. And if we were to have an initial condition here, like Christian's going to have on its homework. So we have, so let's say x is 1, y is 2. And so what that does is it takes that slope field right there and it traces out a line that would go through that coordinate according to any of these. What a slope field does is it gives me a graph of what it could be given any xy coordinate. So if I do another one and just say that the xy is going to be -2 and -3, it will go through that coordinate. There it goes. So it fits along right here as long as it fits that point right there. That's my initial condition. So please write these down on your notes on how to actually get to this, because this is kind of a pain and then if you enter y, you have to put y1 on it. Now, it used to be that you had to put y prime instead, but I guess there was an update to this to actually just call it y1. Alright, so we have that one. Use slope field to represent solutions. Use slope field to draw some graphs of the family of solutions to the differential equation. So that's what we have here. With any given coordinate, I could change this according to whichever point I want it going through. Okay. Which of the following differential equations could have a slope field shown with this? So, what shape is this? Look at those fields. It looks like it's making a shape of a parabola, isn't it? Okay. So, right here on the on the y-axis here, what's the slope going along the y-axis? 0, right? So my slope, my dy dx, on any given y value should give me 0, right? Any given y value should give me 0. So if I have my x is 0 right here, my x is 0 along this, so I should get 0. Okay, so now, does this first one work? It could work, but what's the problem with this right here, the negative slope field? It would be flipped, right? Now, let's look at it, and now let's say 1, 0, 1. So if I plug in the coordinate 0, 1, 0, 1, my slope should be, shouldn't it be 1? dy dx should be 1. So is that 1? Nope. There we go. Same thing goes for question D. So right here, when x is 0, the slope is 0, right? So when you're looking at these problems to identify what slope field could work, look at something that's a 0 all the way across. That means that when that value right there, when x is 0, the slope is 0. And it would go the same thing going the other direction if I had a flat going horizontally. So I mean, if the y is 0, the whole thing would be 0. So I'll give you an example of that right there, of what I just said. So let me go doc. Nope. Menu. Differential. And now, looking at this, so when the y is 0,
How do you graph that?
let's get rid of that one right there. So when the y is 0, so all of these are just based on, so if the y value is 0, so that means that everything is based on what the x is. So if the y value is 0, my slope is going to be whatever x value is. So right here, y value being 0, the slope would be 1. Right here. So depends on that. So the shape and the pattern, it depending on how many variables that you have. So if I look at another one, and let's give it an x and a y. Give it an x and a y. So now if you guys are looking right here, what is this key to that? There is a flat spot right there, right? So that flat spot means that the slope is 0 at those points right there. So now here and here, that's going to give me a slope of 0. So that means that the x and y cancel out at that coordinate, right? So whatever my x is going to like subtract from my y, or either way. You're going to have problems like this on the free response. You're going to have to match these. Not free response, multiple choice. You're going to have to match these. So that's going to be key. Look to see where your zeros are at. And majority of the time, you can eliminate some of the problems like we did right here. Make sense? Kind of? Alright, so like I said, I'm going to pick up the rest of this on Monday. Tomorrow's an I day. And was 5-6 due yesterday? No, today. 5-6 is due today. I think so.
How short is 5-6? Wait, we finished 5-6?
Yeah, that was just one day.
No. Oh, okay, no.
Alright.
Confused the other one.
Like, share, and subscribe.